And welcome. Today, we're going to talk about something incredible. A force that's both super powerful and unbelievably patient. I mean, it's happening all around us all the time, shaping everything you see, from the biggest mountains right down to the soil under your feet. Yup, we're diving into weathering, what I like to call Earth's unseen sculptor.
So, let me ask you this. What if I told you there's an invisible artist out there, constantly sculpting our world? Chiseling away at mountains, carving up rocks, and even creating soil. Well, that artist is weathering. It's this relentless natural force that just breaks down rock. And today, we're going to get into exactly how it does its magic. All right, here's the game plan. First, we'll nail down what weathering actually is. Then, we'll check out the sculptor's toolbox. We've got the hammer, that's physical weathering, the solvent, which is chemical weathering, and even a living chisel, biological weathering. And to wrap it all up, we'll step into the sculptor's studio to see how climate runs the whole show. Okay, let's jump right in. Time to get to the bottom of this. What exactly is this incredible process that's shaping our planet? So, here's the official definition, but let's make it simple. Weathering is just the process of breaking down or even dissolving rocks right where they are. Geologists have a cool term for this, in situ, which just means in its original place. Now, the really important thing to remember here is that it's a static process. It's all about breaking the rock apart, not about carrying the bits and pieces away. That next step, that's erosion, and that's a whole other story. But this first step, man, it's so vital, because this is how we get the basic ingredients for soil. To really get this, you got to think about the Earth being in this constant push and pull between two types of forces. You've got your endogenic forces. Those are the ones from inside the Earth building things up. Think volcanoes creating new land. Then you have the exogenic forces. These are the external ones working on the surface. And you guessed it, weathering is one of the main exogenic forces, constantly tearing down and reshaping what those internal forces have built up. All right, time to check out the sculptor's first tool. Let's call this one the hammer. And yeah, it's exactly what it sounds like. We're talking brute force, the pure mechanical breakdown of rock. So physical weathering, some people call it mechanical weathering, it's super straightforward. It's literally just the process of breaking big rocks down into smaller pieces of rock. But here's the most important part. The chemistry of the rock doesn't change one bit. It's the same exact stuff, just smaller. So you're probably wondering, how does this actually happen? Well, the main culprits are big swings in temperature, the amazing power of ice, and this really cool process called exfoliation. Okay, let's talk temperature first. Picture a hot desert. The temperature swings from day to night are just huge, right? So during the day, the rocks bake in the sun, they get super hot, and they expand. Then at night, it gets cold, and they shrink back down. Now imagine that happening day after day after day. All that expanding and contracting puts a ton of stress on the rock until eventually, pop, it just cracks and breaks apart. And this can lead to something that's got a great name, exfoliation. You know how a snake sheds its skin? It's kind of like that, but for rocks. The outer layers just start peeling and flaking off because of those intense temperature changes. It's a perfect image, right? A rock just shedding its skin. Okay, now let's talk about frost action, because this stuff is seriously powerful. It's a simple process, really. Step 1, water seeps into a little crack in a rock. Step 2, the temperature drops below freezing. Now you might remember from science class, when water freezes, it expands by about 9%. That expanding ice acts like a powerful wedge, forcing the crack just a little bit wider. You just repeat that cycle, thaw, freeze, expand, thaw, freeze, expand, and before you know it, that tiny crack has completely shattered the rock. Okay, so we've seen the hammer. Now it's time for the sculptor to put down the brute force tools and pick up something more subtle. Let's call this the solvent. And this is where things get truly transformative. See, chemical weathering is a whole different ballgame. We're not just talking about breaking rocks into smaller pieces anymore. No, we're talking about decomposing them. This is where chemical reactions actually change the minerals inside the rock, turning them into something brand new. The rock's fundamental chemistry is completely altered. And how does this happen? Well, there are a few key chemical processes at play. The big ones are oxidation, carbonation, hydration, and solution. Let's start with oxidation, because I guarantee you've seen this before. You know how metal rusts? It's basically the same thing. When oxygen, usually from rainwater, hits minerals that are rich in iron, the rock literally starts to rust. That's why you see so many rocks with those beautiful, rich red and brown colors. That's rock rust. Then you've got carbonation.
This is when carbon dioxide from the air mixes with rainwater and it forms a really weak acid. Now, weak acid might not sound like much, but over thousands of years it's powerful enough to dissolve entire rocks like limestone, creating massive underground caves. And then there's hydration, which is even simpler. Some minerals just soak up water, swell up like a sponge, and that makes them weak and crumbly.
Okay, so let's do a quick side-by-side. Physical weathering, it just breaks rocks. Chemical weathering, it decomposes them. Physical, chemistry stays the same. Chemical, the chemistry totally changes. And where does this all happen? Well, think of it this way. Physical weathering is the king of hot, dry places and cold places. But chemical weathering, it loves it where it's hot and wet.
But wait, our sculptor has another tool in the bag, and this one's a little different. It's not just about ice and rain. Sometimes life itself becomes the chisel. And that, my friends, is biological weathering.
This one's really cool because it's kind of a hybrid. It uses both physical force and chemical reactions. A classic example? Tree roots. They worm their way into tiny cracks and then just push the rock apart. That's physical force. You've also got animals, rabbits and worms, digging around and loosening things up. And then there's us, humans. Our mining, construction, farming, it's basically biological weathering on a massive, super fast scale.
So, we've seen the hammer, the solvent, and the living chisel. We know the tools. But where does the sculptor actually do all this work? Well, that brings us to our last stop, the sculptor's studio. And the studio is the climate.
When it comes right down to it, climate is the most important thing that decides which type of weathering is going to be the main event in any given place. So, if you're in a hot, dry desert, it's all about physical weathering from those crazy temperature swings. In a hot, wet place like a rainforest, oh yeah, chemical reactions are in overdrive. And in colder places, that powerful freeze-thaw cycle of frost action is the boss.
And check this out, here's a really interesting twist that connects to our world today. For the longest time, scientists figured the polar regions were all about physical weathering, frost action. But what they're finding now is that as the climate warms up and the ice melts, it's exposing all this new rock. And guess what? Chemical weathering is starting to kick into high gear up there. It just goes to show you how connected and dynamic this whole system is.
So, after all this, what's the big takeaway? The main thing to remember is that weathering isn't just about destroying things. It's actually the very first crucial step in creation. It takes solid bedrock and grinds it down into the tiny particles that become the foundation for soil. And without soil, well, there's no food, no forests, no life as we know it.
And that leaves us with one last big question to chew on. We've established that the climate is the sculptor's studio. It sets the rules. So, as we humans continue to change the climate on a global scale, what does that mean for the sculptor? What new tools will this invisible artist start to use? And what will our world look like when it's done? It's a pretty powerful thought, isn't it? Thinking about our place in this ancient, incredible process.